Welcome everyone, and thank you for joining us. Today we have a very special guest with us. He's Richard Shea. He's a principal security data scientist here at ThreatTrack Security. And today we're going to talk about Richard's newest white paper. It's called Data Science, the Engine to Power Next Generation Cybersecurity. And just to kind of lay the groundwork for the audience, one of the reasons in your paper, and the reason it's so important, is because it talks about some of the incidents that have happened recently and the ineffectiveness of SIM solutions to try and stop those attacks.
Right.
Can you talk a little bit to get us started about SIM solutions and why they're not effective against some of these attacks?
So SIM stands for Security Information and Event Management. So it's originally designed for helping the enterprise IT department to better handle the system logs information or net flow information. So they put the log information from different sources, correlate them, and present them to the security officers, and do some basic, analytics work. But its limitation, its strength is, doing the log analysis and log processing. But that doesn't represent all the information. All the data happen on your network. So it doesn't provide you a full situational awareness on your network, on your enterprise, or in the organization. What's happening is there. So, and also, most of the analytics are based on signatures or based on rule sets. So it's kind of, they try to extract the rules or signatures from what happened in the past and use those rules to predict what is going to happen in the future. But currently, the modern hackers are getting more and more sophisticated, and they rely on data science or machine learning to get around those preset rule sets or signatures. So it's really hard for the traditional or conventional SIM system to keep up or catch up with the tactics or strategies used by the modern hackers. They usually can find a way to go around the SIM system and get into your system. So we need to be more agile, be more adaptive, and in most cases, the enterprise organizations, they rely on traditional IT department to look after those security information or security events. They are not specially trained security officers. So the SIM system usually assume the audience or the users have the security background, but most often they don't. So the IT department, the just ordinary IT professionals, they need more user-friendly UI, the user interface, and more actionable intelligence, and more reasonable evidence to get the security information, get the situational awareness of their network. So that's what we say we need a next generation of the cybersecurity solution, which not necessarily just get rid of SIM once for all. It's more like we can work with SIM system, but it will be just part of, the SIM is just part of the whole solutions. We need better analytics, we need better data, we need more data, we need big data, and we need more advanced analytics to turn that big data into something valuable, useful, and actionable.
So I want to ask you more about big data, but
Right.
first I sort of want to lay the groundwork for the audience. So the 2016 Verizon Data Breach
Right.
Report came out recently. It looked at 20,000 incidents, looked at 2,000 data breaches, and you talked about the ineffectiveness of SIMs. But even beyond SIMs, when you look at IDS, IPS, when you look at firewalls, and all the other technologies are out there, they're finding all of those are ineffective in that the attackers are actually gaining ground as we go forward.
Right.
What is the role big data is going to be able to play to slow this down, to stop this?
So we always have big data, in the realm of cybersecurity, because we're dealing with network, we're dealing with internet. So every day, every second, the internet or the enterprise network is generating a huge amount of data, from thousands of computers from different devices, using different protocols and the services, different like file types, like attachments on the email. So we're generating a huge amount of data. So that's the reality of big data. But sometimes people confuse with, confuse the reality with solution. So they say big data would be the solution to solve our cybersecurity challenges. But big data alone is not enough. So big data basically just a reality. We have to deal with that. So we need to turn such reality into solution. What's in between? So we need a tool. So this tool is data science. So data science is the tool with the help of the distributed computation, with more powerful machines, we can turn such big data, the reality, the resources, into a more intelligence, more insights, more knowledge, or more situational awareness of a network, so that we can not rely on preset rule sets or signatures, but we constantly learn from the big data, because big data is moving, is evolving. Every day we generate new data. So the new data may be different than the data we generated yesterday. So we need something, we need some robust mechanism to constantly learn from the data, to be adaptive to the new reality, so that we can refresh the knowledge, refresh the insights we get from the network data, so that we can defend against the hackers. So big data is really giving us enough raw material. I always use this analogy. It's like we are powering a train. So we need a lot of raw material, but raw material or coal is not enough to power the engine, to move the train. We need something to burn the material and turn the raw material into energy. And it is energy that moving the train. And so data science will be the engine to burn the material, to extract the insights, and we use the insights, which is the energy, to move or to drive the cybersecurity solutions.
Okay. So let's talk about where we are today and where we're going with big data.
Right.
When you look at a lot of organizations or security operations centers, what you find is they have an SQL database or a non-SQL database like Mongo.
Right, right.
And they're gathering this data today, but they're not really gaining insights from this data.
Yes.
What do you think they have to do in order to take the next step to gain actionable insight from this data?
That's a great question. So data science is it's a really sophisticated field or discipline. So, but by and large, in general, data science has 4 stages. The first is descriptive analytics. You're trying to use the data, gather the data, and use the data to describe the situation. Use the statistics, use mathematics, use the numbers to trying to just use abstract way to visualize it or summarize the situation you're currently in. So that's the first stage, descriptive stage. And the second stage is diagnostic stage. You have some like accident, you have some results, but you want to find out why that result or why that accident happened. So also like forensic. So you take the result and look into the data you have gathered. You're trying to find the reasons or the causes for that result. So that's diagnostic stage. And what you have said, a lot of organizations, they have the database, a SQL database or no SQL database. They gathered a lot of information, but they just use the information to try to find out, if something bad happened to the organization, if they can find out some evidence in their database to be related to that cause. So it's more like a forensic. It's more like post-event investigation. So that will be kind of, within the 2 stages, descriptive and diagnostic. But more important stages are the next two stages, which is the predictive stage, and the prescriptive stage. Predictive stage is we gather a lot of data, we gather all the evidence, we're trying to predict what's going to happen in the next. We're trying to use the data we have collected to predict the future, and before something really bad really happened. So that's a predictive stage. That's the power of we use data science to defend against any cyber attackers. And then the prescriptive stage is more like is what we should do, what decisions we should take. So that's more leaning towards the decision science, going from data science to the decision science. So based on the results from predictive learning, predictive analytics, we predict such events would happen. Then based on all those things, we would say, okay, what actions we should take to optimize our results, to prevent those things to happen. So that's more like what we should do. So predictive analytics is what's going to happen, what's going to happen next.
So Richard, you talked about a variety of different statistical methods that you use in your paper in order to draw conclusions from this big data.
Right.
Can you give examples of 2 or 3 statistical methods that you would use in order to gain insights?
Sure. One of my research topic, and which is going to be integrated into our product, which is Threat Secure Network, TSN, is called the Deep MBA, Deep Network Behavior Analysis. So we extract a lot of data from the network traffic data, network traffics, and TSN do the packet analysis, extracts the detailed information from the traffic. Then we use those raw data, the traffic data, to gather the situational awareness of not only laterally the network, but also longitudinally for each of the IPs on the network across a time frame. So we build time series of a behavior profile for all the IPs. So we call it Deep MBA. The term deep is in terms of the data we collected, the details we collected from the raw data, and also in terms of the analysis we conducted on top of that data. So we use methods like graphic analysis, like graphic network analysis, because that's a perfect fit for the network data we are gathering. So graphic analysis give us very good insight about what are the most critical IP on your network, and it's changing. So whether IP is critical or not really depends on how much traffic goes into or goes out of that IP. So it's not someone saying, okay, that IP is critical, but the data tells us that IP is really critical asset on your network. We should take great effort to protect that asset. And also, the graphic analysis can help us identify the attack path. So after we identify that critical asset on the network, we can identify what are the paths go from other IPs to that IP. Yep. So we can cut off, we can kind of strengthen the protection around the perimeter and cut off the attack path if one of the computers get compromised on the network, so that we can protect the valuable asset. So that's the one of the graphic analysis methods can provide us the insights to the whole network situational awareness. But in terms of the longitudinal, for each of the IP on your network, we use very sophisticated feature engineering to identify the concepts for the IP's behavior, like the concepts like background network services, like the social media services, like the database services. When you live in work and the computer is on your office, it's doing the background services, some background work, some background services are still running. So we identify that concept. But when you come back to office, you start working on your daily job. You get connected to the database. You connect to the FTP server. You're using the DNS server. You're going social network. So those are the concepts lay on top of each other. And we use deep learning. We use topic modeling. We use general clustering methods to identify those concepts. Instead of just raw data, but we extract those concepts so that we can understand and intuitively make sense to us, and build concepts on top of it, and use those concepts to protect against the hackers. So when hackers get into your system, your computer will behave differently. So it will assume different concepts than the concept you usually have. We compare that. We use the anomaly detection to immediately identify there's some behavior changes on your computer. So that would raise a flag. So that's the real power of using different methodologies from data science. Data science is really rich. So use different knowledges or techniques from data science to, the whole purpose is to get the situational awareness. We understand what's going on. We understand what has been like in the normal life, and what is going on now, and what is changing, and what we can do to deal with the changes.
So at the beginning of the interview, we talked a lot about the perimeter defenses and how they're really not working. And then we talked about big data and how everybody's now investing in big data. But you're talking about what they can do with this big data using statistics, and specifically creating situational awareness within their organizations. Now, another term that comes up all the time that people have 100 different meanings to is predictive learning. Can you talk about what that means to you and solving this problem from your perspective?
Yeah, I know there are a lot of fancy terms in data science. Predictive learning is one of them. So, as I said before, I just recap what we have talked about, the 4 stages of data science. So descriptive stage, diagnostic stage, predictive stage, and prescriptive stage. So predictive learning is within the predictive stage of predictive analytics in that stage, in that part of the work. So basically what it means is what it says. It learns to predict. It learns from the past data, the observed data, the known data, and trying to extract the knowledge, or using mathematical models, using the rule sets, using decision trees, different format to represent the knowledge we have learned from the past data, and use that, carry the knowledge to try to predict the unknown events, something in the future. That's based on the assumption that history repeats itself, although it might be in a slightly different format or in a different form, but most of the time it works. Predictive learning is really powerful. The history does repeat itself. But the quality of the predictive learning really depends on how much or what you have learned from the past. As we all know very well, signature-based malware detection engine, signature-based engine, sometimes miss a lot of new variant of malware, but behavior-based malware detection engine can catch them, because signature-based engine learn from the malware based on the signatures they extracted. But behavior-based is what they have learned is the behavior of the malware. So that's the power of sandbox. We run the malware in our sandbox and gather the behavior patterns or characteristics, and use those features to create the behavior-based malware detection. So that's one example. Another example is again in the network intrusion case, in the TSM. So we have known that the hackers have been using a lot of like code injection or social engineering. They send you a very friendly email, saying, okay, if you want to click, you want to see this picture, click this link, or send you very convincing attachment, say this is such and such, and if you open the attachment, some Trojan or some malware will be installed on your network. So that's how they get into your enterprise network. And sometimes they use contractors' network to get into your network. That's what happened to OPM and the Target.
Raising credentials.
Right, yes. So they get into a parameter network and use their network to get into the target system. So with TSN, we have the intelligence built in. So first, TSN would detect the link is malicious, or the file attachment would be malicious. But even if it missed, okay, so we say the hacker has already got the malware installed on your network, on your computer. So your computer would be the stepping stone for the hackers to get into the more valuable assets on your network. But your computer would start connecting to the command and control of the hacker, get the instructions, right? Then also your computer would start scanning the whole network. That's called the reconnaissance, to gather information about your network and trying to identify what's the most valuable asset on the network, right? So when your computer is doing that, connecting to a unknown external IP and also scanning the whole network, it's behaving differently. So based on the behavioral model we have been talking about, the models, the profiles we generate for each IP, that's a divergence from the normal profile, the normal behavior your computer is usually doing. So we will identify that. We will detect that such anomaly and raise a flag. So before the hacker really get into the valuable asset, we already know this computer is compromised, and we will cut off the attack path. You have no way to get into the valuable assets.
Great.
So that's how we use predictive learning and also use data science, a lot of techniques in data science to identify the attacks. And before any bad consequence happens, we cut it off.
Great, thank you, Richard. That is a ton of great insight for our audience. For anybody that wants to download Richard's white paper, you can get it at ThreatTrack.com/resources, and the paper is called Data Science, the Engine to Power the Next Generation of Cybersecurity.